Okay, guys, this is going to be another way to do binomial probability, and it's going to be your favorite. Okay, the reason I showed you the first video with the formula is because I wanted you to know what your calculator is going to be doing. Because the binomial formula is programmed into your calculator. Yeah. Okay, so rather than you having to do that formula by hand, I'm going to show you how to make the calculator do the formula. All right. So after you go through this video, what I want you to do is go back to the other video using the formula. And I want you to try to work those problems along with that first video with your calculator. Make sure you're getting the same answer. So that will give you multiple problems using the calculator. All right. So I'm going to share my screen with you. All right. And let's talk you through it. Now, remember with binomial probability, just a quick review. You can only have two categories. All right. So it could be things like you pass or you fail. You roll a two on a die or you don't roll a two on a die. All right. It could be you live or you die. All right. So there can only be two categories for it to be binomial. And then the one that's really crucial is the second condition here. The probabilities have to be consistent for the whole problem. So they can't change in the middle of the problem. All right. So if your chance of guessing on a test and getting question one right is 1 out of, say, 4, then your chance of guessing on every question has to be 1 out of 4. Okay. So the probability can't change in the middle of a problem. So that's the main thing. All right. So the probability can't be for the same category. It can't be different in one part and then switch and be different in another part. All right. So I'll kind of show you what I mean by that. Now, here's what's going to happen on the calculator. On the calculator, all right, you go to second bars. All right. Now, let me get my calculator. Okay. So when you go to your calculator and you do second bars, there's a home menu that comes down. Like mine says DISTR for distribution and draw, and it's got a whole bunch of things. All right. So there's on number 7, there's a down arrow. What that means is there's some more things in the menu that are below the visible part of the screen. So I'm going to go to my down arrow and I'm going to keep coming down until I see binomial PDF like this one and binomial CDF. Those are the two things that you're going to be using to work binomial probabilities. And there's a difference between the P one and the C one. Okay. But you go to second bars and you scroll down until you find binomial PDF or binomial CDF. Now, here's the difference in those two buttons. And if you don't use the right button, you won't get the right answer. All right. So we got to be careful. Like in the first video, when it's a binomial problem, I still expect to see P, and in a parenthesis, what you're trying to find the probability of. And if you decide it's binomial, I still on your paper, on your test, or on your homework, I've got to see N equals, P equals, Q equals, and R equals. If I don't see those, I'm not going to take the calculator. All right. Now remember what they stand for. N is your total. All right. P is the number in the parenthesis with modifiers. So exactly 3 would just be the number 3. At least 3, remember, would be 3 or more. More than 3, you'd start with 4, okay, and have a whole list. All right. At most 2 means 2 is your max. All right. So it'd be like 0, 1, or 2. At least 2 would be 2 or 3 or 4, all the way up to your total. So just make sure that you don't just glance and see the number that's written. Make sure you look at the modifiers to write next to X. Then look next to X. If there's one number only, I don't care what the number is, 1, 0, 117. If there's one number only next to X, you're going to use this P, binomial PDF. P stands for particular, one particular number. Okay. If when you look next to X, there's a list that starts with 0, it can't be any list. In other words, you have more than one number and that list of numbers has to start with 0. If that's true, then you're going to use the binomial CDF key. And C stands for cumulative, like more than one. And then the order's the same, all right? So you got to be careful though, because you probably have on your paper NXPQ, but in the calculator, it's going to want 3 values in a parenthesis. Now, if you've got an older machine like me, you're going to see in a minute, all that's going to happen when you do binomial PDF is it's going to put binomial PDF and put a parenthesis, and then the cursor's waiting for you to do this, to type in N and a comma. Now, your comma is above your 7 on your calculator, all right? Then to type in your P value, and then another comma above that 7, and then to type in your X value, and then to close your parenthesis. And that closed parenthesis is above your 9 key. All right. So you scroll down and find binomial PDF, you enter, and then you type in your N, a comma, your P, a comma, and your X, and you close the parenthesis, and you hit enter, and the answer just pops up. It's fabulous. Okay. But if you type them in the wrong order, it's going to get mad at you and give you an error message. So it's N and then P and then X. Now, if you've got one of the new machines, it'll say something like, it's better. I mean, it's cooler. Instead of it just opening a parenthesis, when you do binomial PDF and you hit enter, it's going to say number of trials. That's your N. Successes, that's your X. Okay. So I mean, successes, that's your P, like your probability of success. All right. So you may have to play with it a little bit to see how your particular machine does. And then when you hit enter, it types it in for you. And so then you see the same thing that I'm seeing right here. Now, binomial CDF is the same order. You hit binomial CDF, and then you're going to do your N and a comma and a P and a comma and then an X. Now, people freak out a little bit because you got a whole bunch of numbers next to X. But remember that the list has to start with 0. The calculator just needs to know what's the biggest number in the list. So you just type in the largest X value next to X. All right. And then you hit enter and boom, the answer comes out. All right. So we're going to work some to kind of show you what's happening. All right. So look at this particular problem. This is actually a true statement. 10% of people, so the general population at large, 10% of people are left-handed. So in a room of 25 people, find the following probabilities. Well, the first one says, find the probability that exactly 3 are left-handed. So notice what I have to see. I've got to see a P, and then what you're trying to find the parenthesis of, and what you're trying to find the probability of in the parenthesis. So that's why it says exactly 3 are left-handed. Well, now, either you're left-handed or you're right-handed. The chance of being left-handed in this problem is always 10%. So I've got 2 categories, and for this whole problem, the chance of it being left-handed is 10%. Now think about it. You're either left-handed or you're right-handed, okay? And think about it. If it's a 10% chance that you're left-handed, the rest, 90% would be the chance that 10% that you're left-handed, 90% chance then the rest that you're right-handed, okay? So it's a binomial problem. So I had to write down N, X, P, and Q. Now remember, N is my total, so I go back in my problem, there are 25 total people. So that's why there's a 25 next to N. And then I go back and look for the number in my parenthesis, 3, but I look at the modifiers. Exactly 3 is only the number 3. So there's only the number 3, one number next to X. Now remember what I said in the video before. P and Q are probabilities of categories. There's only 2 categories. P is the probability of the category in the parenthesis. So just cover the number up and look at the parenthesis. We decided it was either left-handed or right-handed. Those are my 2 categories. So which one's in the parenthesis? Left-handed. So what's the probability you're left-handed? It says 10%. Now remember, probability's got to be between 0 and 1. So it can't be 10. It's 10% is the decimal, 0.10 or 0.1. All right. So 10 hundredths and 1/10. There's just 2 ways of saying the same thing. And then remember, the way you get Q is 1 minus P. All right. And 1 minus 0.1 is 0.9. All right. So 1 minus 1/10 is 9/10. So because there's only one number next to X, I go to second bars, I scroll down, until I find binomial PDF and I hit enter. Now, on my machine, I've got to scroll down for a while. On mine, binomial PDF's like, it says 0 next to it. Okay, so always past 9, it's really 10. All right. And then I type in a 25 and a comma. Remember that comma's above the 7. My P, I go back over here and find it, is 0.1. So I type it in a comma. Then I go back over here. My X is 3. And then I close my parenthesis. Remember, that's above your 9 and hit enter. And the calculator puts up a really long decimal that I rounded to 4 decimal places, 0.2265. So 2,265 10,000ths. Okay. Now, what if instead the problem had said 10% of people are left-handed, and in a room of 25 people, find the probability that at most 20 are right-handed? I've changed the problem. So I've got a P, at most 20 are right-handed. Now, you need to be real specific so you don't get lost. So what does it most mean? All right, remember what it most means. Most means that's the max. I mean, if that bridge holds at most 2,000 pounds, that means it can't hold any more. It's got to be that number or below. So write down what it literally means. At most 20 literally means 0 or 1 or 2 or 3 or 4 or 5 all the way to or 20. 20 would be the highest, or right-handed. Now, if it had said less than 20, I wouldn't include the 20. I would have stopped at 19. Okay. But this said at most 20, so I have to include the 20. Now, again, either you're left-handed or you're right-handed. Your chance of being left-handed in this problem is always 10%. So that means your chance of being right-handed is the rest, 90%. Those probabilities aren't going to change, so it's a binomial problem. So my N is my total, so I go back and read there are 25 total, and then I look in my parentheses, at most 20, not just 20. Don't just glance and write down the number 20. That's why writing out exactly what it means is super important, okay? So I write down the 0 or 1 or 2 or 3, it'd be all the way to 20. So I got 21 numbers that I need to worry about, okay? And then P is the category in the parentheses. So they'll fool you. Sometimes the problem will have one category, and then the question will have a different category like this one. So you got to be real careful. This says right-handed. So that's why my P is my chance of being right-handed. So it's 0.9. And then 1 minus that P is where I got the 0.1. So see up here, my category is left-handed. So my P is 0.1. Down here, my category is right-handed, so my P was 0.9. Now, look what I've got. I've got a list of numbers. A list just means more than one, all right? And my list starts with 0. So that's how I know I can do this binomial CDF key. And so I type in my N, I type in my P, and then remember, this is my biggest X. Because what the calculator's doing is this. Remember in the last video I told you, here's your other alternative. You could go up here and you could use the binomial P key 21 times. You could let N be 25, and you could let X be 0.9, and you could let your P value be 0.9 and your X value be 0 and get that answer and save it. One particular number. Then you could go repeat it with the binomial P, because you can only have one number, and let X be 1. So I'd have a 25 and a 0.9 and a 1. I could do that for every one of these numbers. And then because it says or, I could add them all up. But who wants to do that? Why would you not want to use one key one time? Okay. So when you got one number next to X, use the P key. When you got a list that starts with 0, use the C key. And this number right here is the biggest X in your list, because that's what the machine is doing. The machine is finding the answer when X is 0, finding the answer when X is 1, finding all 21 of those answers and adding them up for you and just giving you the final total. It's pretty sweet, isn't it? All right. So P when there's one number, C when there's more than one number, but the list has to start with 0. All right, let's look at another one. All right, 10% of people are left-handed. So in a room of 25, find the probability that at least one is left-handed. So again, I put the probability that at least one is left-handed. Now remember what at least means. At least doesn't mean less than. So be careful. You have to have at least $10 to get into the movie. You can't get in with $5, but you can get in with 20. So at least means that number or more. So write down what at least one literally means. It means 1 or 2 or 3 or 4, all the way to your total, 25 in this case, are left-handed. All right. So here's what I need. So either you're left-handed or you're right-handed. Your chance of being left-handed is always the same in this problem, so it's binomial. So I write down my N, my X, my P, and my Q. So again, what's my total? 25. What's my X? Well, I go back to my list and I've got 1 or 2 or 3 all the way to or 25. So there are 25 different numbers. My category is left-handed, so my P has to be my chance of being left-handed. So 10% as a decimal is 0.1. And then remember, Q is 1 minus P. So 1 minus 1/10 is 9/10. So I think I'm ready to go. But I got a problem. Remember the two keys, binomial PDF and binomial CDF. Now, when do you use binomial PDF? When you've got one number next to X. Well, I got a bunch of numbers, so that won't work. I think, oh, well, I got a bunch of numbers. I got a list. I'll use the C key. Oh, can't do that either. Why? Because remember I said the list had to start with 0, and my list doesn't start with 0. Now, I've got two choices, and one's a whole lot easier than the other one. Here's one choice. I could use the binomial PDF key. All right. I could use that key and just use the 1. So I could go over here and do I could do that binomial PDF and do my N is 25, comma, P is 0.1, P is 0.1, comma, X is 1, and get that answer and save it. Then I could start over. And this time I'd start over and I would let X be 2. Okay. So let's go do it again. Okay. So now I'm not going to use the 1 anymore. Now I'm going to start over and do binomial PDF and let my X be 2. So I've got binomial PDF, so I could have like a 25, comma, a 0.1, comma, and a 2, and close the parenthesis and get that answer and save it. And I could do this 25 different times. So I've worked binomial PDF 25 different times and saved all 25 answers. And then because the probability says or, remember, what do you do with or probabilities? You add them up. I could add 25 answers and be finished. Well, you can do that, but I'm not going to do that. That's too much trouble. So on the test or on the, anytime on your homework, when it's a binomial problem, you think, oh, I'm not doing it that way. That is too much trouble. Another option should pop in your head. I could do 1 minus the probability of the complement. Now, what do I mean by that? All right. Well, the complement is everything in the sample space that's not in your original list. So think about it. If there were 25 people in a room, how many could be left-handed? I wrote the sample space down. There could be 0, 1, 2 left-handed people, 3 left-handed people. These are all the number of left-handed people there could be out of 25. So if I want the complement of this, so 1 minus this, then I've got to go down here and I've got to cross out all of these numbers. Okay. So if I do that and I cross out all the numbers that are up here, if I cross all of them out, don't know why this is not wanting to do. Let's see if I can get it to work. The only thing that's going to be left is the 0. All right, so if I delete the 1, the 2, the 3 out of this list, so if I delete from 1 all the way up to 25, the only thing that's going to be remaining doesn't want to do it, is the 0. So 0 is the only thing left out of that sample space when I delete all of these. Well, now I'm working this problem. Okay, so now all right, I'm going to have to start over and work this problem. So this is my N, X, P, and Q with this box problem. There's still 25 total, but now the number in my parentheses is 0. My category is left-handed, so that's why my P is 0.1. And then remember, 1 minus P is Q, so I get 0.9. Now, do I use the P key or the C key? There's one number next to X, so I use binomial PDF. I type in my N, comma, my P, comma, and my X, and I close my parentheses, and this comes up on my machine. But this isn't my final answer. This is just the answer to the boxed problem. I've still got to do 1 minus that answer. So when I do 1 minus that answer, I get this one, and then I rounded it to 4 decimal places, 0.9282. Okay. See if we can get it to go to the next one. All right. Let's work a different one. Okay, maybe. All right. See if we can get it to erase this stuff. Okay. All right, let's erase this. All right, now, look what this one says. 10% of people are still left-handed, all right? And remember, 25 people find the probability that at least 10 are right-handed, okay? So at least 10 are going to be right-handed. Now, remember what at least means, that number or more. So I literally wrote down that means 10 or 11 or 12, all the way to the total 25 are right-handed. Well, again, you're left-handed or right-handed. Consistent probabilities is a binomial problem. So here's my N, my X, my P, and my Q. So my total, there's my X, and my category is right-handed, so P's got to be the chance of being right-handed, so that's why P is 0.9, and Q is 1 minus that 0.1. Now remember what my option is. I've got a problem. I can't use the P key just one time because I got a bunch of numbers. I can't use the C key because my list doesn't start with 0. So again, I've got 2 choices. I can use the P key and let X be 10 and get that answer and save it. I could use the binomial PDF key and let X be 11 and get that answer and save it. And 12, I could do it like 16 times and get all 16 answers and add them up. Again, I'm not going to do that. You can do that. Somebody on the test will do that, and you will get all the credit. I'll just salute you, but I'm not going to do that. That's too much trouble. So remember what I said when the thought pops in my head, oh, that's too much trouble. Then I'm going to think, well, I could do 1 minus the probability of the complement. Well, I can only do the complement if I can name the complement. What's the complement? The complement are all the numbers that are missing up here. Well, what possibilities are missing? 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. Those are the missing numbers, or, and my category stays the same, right-handed. So I'm going to work this problem instead And then I've got to remember though, when I work this problem and I get I get it from the calculator, I'm not going to be finished. I've got to say 1 minus this answer. Now look at why I'm going to like this problem better than this one. My n is 25. These are the numbers in the parentheses, 0 or 1 or 2, all the way to or 9. My category is right-handed, so that's why it's 0.9, and 1 minus that's 0.1. The list up here, and I got a list down here. Why do I like this list better? Because it starts with 0. And see, if this list doesn't start with 0, its complement will. And I like a list that starts with 0 because I can use the binomial C key just one time. So I typed in my N, my P, and then the biggest number in my X. And this is what I got on my machine. Now, this is scientific notation for Texas Instruments. This really means times 10 to the negative 11. It's a way of writing a real small number. For most of us, I don't want your answers in, you can write them in real scientific notation, but not this fake scientific notation. That means it wants you to move the decimal 11 times, and because it's negative, you move it to the left. If this were a positive 11, you'd move it 11 times to the right. So when I go around this one time to the left, I'm still going to go around 10 numbers. So that's why there are 10 zeros. So this number times 10 to the negative 11 is scientific notation for this number. So that red number is my chance of getting 0 or 1 or 2 all the way to or 9 right-handed. So when I do 1 minus that, I get this. Now remember what I said, sometimes you have to have more than 4 decimal places, because if you went to 4 decimal places, this would round to 0 and you're not allowed to round to 0. So you may have to go more than 4 decimal places to keep from rounding to 0. Now we're going to play with these more, all right? But go back to that first video that I did with the formula and use your calculator and make sure that you get exactly the same answers. On the test, you can use the formula, but it's not on, it's not on your formula sheet. So you're going to have to know it, okay? How to use it. So you're welcome to use the formula, but I and nearly everybody else is going to use the calculator to do the problems. All right. So if you have trouble, make sure that you just come see me. Okay. All right. So I will see you. All right. And if you have trouble before I see you, then just make sure that you email me. I'm happy to Zoom with you or meet in person with you anytime. All right.